All right, good morning. Welcome back to Applications of Calc 2. So we've got an improper integral here, and it's going to be one that's going to require u substitution, probably. So first thing we're going to do is we're going to be good about writing down the limit. Pick your favorite letter. I'm going to pick theta today. It's a Greek letter. We don't get to use it that often, so but pick your favorite symbol. And we're going to do 5 to theta. Okay. 1 over x ln of x. This was purely a whim that I felt like you can use any letter you like. You can use A. I would recommend not using U, but pick a symbol here. Okay. Actually, there came to be a point in the middle of Calc 2. I got so tired of U that I would just start saying, let mushroom equal something. And that's how I did the rest of my Calc 2. So use what you please. All right. We're going to say let u equal, say, the natural log of x du is equal to 1 over x dx. So we've got back to our integral here. So we're going to say we have our limit as theta goes to infinity and our integral of 5 to theta. And then here we have 1 over, what was u? It was it was the natural log. So it's the natural log here times, and all I'm doing is moving this around a little bit because I know that my x dx is really just du. And I know that your book tends to have you guys solve in terms of dx. My book had us do it this way. It's just a slightly different way of looking at it. I'm just more comfortable with having it look like this. We get a direct substitution. You can use the way that your book shows you. You can use this way. I'm sure there's dozens of others, but we're going to try to pick something consistent to do. Okay, so we have theta goes to infinity. We have 5 to theta. It's in 20 years when you guys are doing this, the kids that are doing it for you, they're like, we did it this way. Like, yeah, I know. Looks a little different. It's okay. So we have our du. Okay, and then we just have to go ahead and integrate this. So this is going to be natural log of u going from 5 to theta from limit as theta goes to infinity. Now, technically, I really should have changed my limits to use u limits rather than x limits. This is still x equals. You might want to leave a little x here so that you kind of remember that these are x limits. Okay, so you know you have to go back. Okay, a lot of times I would prefer to like change my limits to u limits rather than x limits, but in this case, we're not doing that. Okay, so we have natural log of u from our values here. So we have limit as theta goes off to infinity of the natural log of what was my u? My u was natural log. So this is going to be the natural log of the natural log of x minus the natural log of the natural log of 5. Okay, so we have that. Now, here we have the natural log of the natural log of x, and you have to go back and think, what the heck does the natural log function look like, right? Y equals natural log of x, which looks something like this. When I take the natural log of this thing, even better, right? It's only going to go from 1 onwards, or it's actually going to go from, you know, from 1 onwards, but not including 1 because that's 0. And that would be the natural log of the natural log is 0. That's not going to work. Okay. So the natural log of the natural log, this thing is going to flatten out even more. Okay. So let me see if I can do it this way. And yay, there's different colors. And right here, we're going to have this kind of a piece where it's going to look even like that, and it's going to flatten it even more here. This isn't going to be a part of it because we can't take natural logs of negative numbers, but natural logs that are between 0 and 1, that's going to be okay. Or I'm sorry, between 1 and e, that'll be fine because there'll be negative numbers in the natural log of the natural log. But we're going to end up with a problem like this. Okay, so even though it's going to very slowly, very, very slowly get to be bigger, if you think of a big enough number, the natural log of the natural log of that number will still be a pretty big number. So in the end, this guy diverges because this is going to go off to infinity. The natural log of infinity is still going to be infinity. And we're never really going to get a thing. So this whole thing diverges and we're done. Thank you much for watching the video. Okay. Good luck with everything. I told you guys a while ago, we did a problem just like this with a little bit different problems. Again, I know that this problem, this particular shape of this problem tends to cause applications of Calc 2 students issues, which is why I ask it a couple of times. Is be good, be able to recognize this one, like know like when I'm doing this and be able to recognize it and know how to handle this integral because you will see it again. Okay. Thank you very much for watching the video. Take care, everybody. Goodbye.